Good morning to all of you. Let's see the another questions related to the straight line where we trying to find out the equation of the required line. It means that with the help of the various form of the line. So as we discussed previously that if the intercepts on axis are given, then we easily find the equation of line. Now let's start with the question number 14 that. Example 14 as per the exercise that a line passing through 0, 2 and also making an angle 2 pi by 3 with x-axis. See that a line makes an angle. A line makes an angle 2 pi by 3. 2 pi by 3 with positive x-axis. I write in short with plus x-axis. So what happened? You can easily find the slope because of that slope is always tan theta when a line makes an angle with positive axis. So slope of a line is very clear. Therefore, slope of a line is m is equals to tan theta. So I just write it as tan 2 pi by 3, right? And tan 2 pi by 3, my dear friend, we know very well that it can be written as pi minus pi by 3. And pi minus theta is in second quadrant where tan is negative. So it's minus tan pi by 3. And minus tan pi by 3 is minus root 3. It means this is the line containing negative slope. Okay, let us try to draw the line. Also one more thing is given that this line passes through 0, 2. Which passes through 0, 2. So this both thing is given in your question. Okay, now let's try to plot this line in R2 coordinate system. That is the way to derive a line. Y-axis is there and here somewhere is the x-axis. Now see that 0, 2 obviously lies on y-axis. That is the point lies on y-axis. And now a line makes an angle 2 pi by 3. So obviously a line must be passing through second and first quadrant like this. Actually we are not sure about that, but with the help of the angle we may easily say that. This is the angle more than 90 degrees. See that is 2 pi by 3. Here is the point 0, 2. So now we know that what is the equation of line? Y minus y1 is m into x minus x. So equation of line is y minus y1, my friend, is equals to m into bracket x minus x1. So let's put the value y minus 2. M means minus root 3 into bracket x minus 0. So y minus 2 is minus root 3 x, and this term if we may write on that side plus root 3x plus y. Plus y and minus 2 is 0. This is the required equation of the line. I hope you easily understand that. Now the question, another question is this. One more question is there. See that find the another equation of line which is parallel to it and also passing through t2 distance below from origin to y-axis. See that 2 distance below. Here is origin 1 and 2 distance below with origin. It means from origin this distance is 2. It is given that, and that is the line which is parallel to the given line. Our another question is find the equation of this second line. So we may say that this point is 0, minus 2. So a parallel line to it. A parallel line to it is 2 distance below. 2 distance below from origin is given here. From origin. It means we may say that it makes y-intercept is minus 2 and slope is same because parallel line. So slope of this parallel line is again minus root 3. So therefore equation of this parallel line is again I directly write is y is equals to mx plus c. I think you easily understand why I write mx plus c. See that this is the line which makes an intercept, y-intercept, and we know that y-intercept is -2 here. Intercept should be positive or negative because it represents line segment. So where this c is -2, let's put the value minus root 3x minus 2. So finally we get the equation as this both term we may write on that side. It means root 3x plus y and plus 2 is 0. Now see both equation. These both lines are parallel. Can you say that here x coordinate and y coordinate are same in both cases? See that root 3x plus y. Here also we get root 3x plus y. It means that our conclusion is this. When two lines are parallel, then coefficients of x and y never can be changed. Only constant can be changed. So remember it. Okay, next question, example number 15. See that this is also one different question, that one line segment is drawn as perpendicularly to the line. It means from origin, one perpendicular drawn from origin, a perpendicular drawn whose foot of perpendicular, yes, whose foot of perpendicular is -2, 9. Our question is find the equation of that line. So nothing to do. -2, 9 obviously lies in second quadrant. So I think that so the equation is this -2, 9. Here is the line. So is again very easy question. See that this is origin or not. This is foot of perpendicular. I hope you understand. Foot of perpendicular means the point which is at right angle. So that is O 0 0. Origin, this is point -2, 9 as per given. So we may easily say that slope of line segment OP, we get it easily. Then we get what is the slope of that line. So it is very easy. Slope of line segment OP and slope of line segment OP is very clear. Difference of y coordinate upon difference of x coordinate, and that's why is -9/2. And slope of line, so slope of required line is opposite and reciprocal to it. Required line is m is equals to -1 by -9/2 is 2/9 is the slope of that perpendicular line. Also that line passing through -2, 9 slope we have. Now it is very easy to find the equation of line. Now this is point slope form. So therefore equation of line we get it easily. Point slope form. So let's write the equation of line. So therefore the required equation of the line is y minus y1, as we know, is equals to m into x minus x1, where what is x1, y1? See the point. A foot of perpendicular already given is -2, 9. Right? Let's put the value. This -2, 9 where point line passing through, and slope is 2/9. So it means y minus 9 is equals to 2/9 into bracket x minus minus plus 2. Now this is your duty to solve it. I think you can solve it in homework. A very easy question. Okay. Next example, example number 16. Here one relation is given. Just read the question. One wire is given whose length and temperature. So relation is given, length and temperature. Relation between length and temperature related to the wire. So let's write in short. Example 16. relation between length and temperature. Length and temperature given as, okay, I write it as L1 C1, length of the wire, temperature. Second relation is given L2 C2. See that in your textbook this relation is given when L1 is 124.942. 124.942. At that time temperature is 20 degrees Celsius. Now when length increase 125.134, 125.134, then this Celsius temperature is also increasing. It means I think those so that heat should be given. So heat should be given for this wire, and that's why length and temperature both increase. Now our question is to find the relation between L and C. So obviously the relation is linear. 2 points are given, these 2 points are given, that's why we easily say that equation of the line is y minus y1. In place of y minus y1, here L minus L1 I have to write. So relation between L and C is relation between length and temperature C is, I must write L minus L1 upon L1 minus L2, my friend, is equals to C minus C1 upon C1 minus C2. Let's put the value, then L minus 124.942 upon 124.942 minus 125.134, right, is equals to C minus C1. C1 means 20 upon 20 minus 1100. So let's get it. L minus 124.942 upon this value you have to find yourself. And here is C minus 20 upon minus 90, my friend. 20 minus 110. Okay, here also negative, because it is obvious that 124.942, see that. So if you add, I think here you get it easily, 134 and plus I think this value is 38. So 134 plus 38 should be the answer. 134 plus 58 maybe, right? 58 plus 42 is 100. So 8 plus 4, 12. So I think 0.292 minus 0.292 is the value, right? Minus 0.292. Okay. Let's put the value. Minus 0.192. So minus minus cancel on both sides, my friend, and 90 is going on that side. 90 into bracket L minus 124.942 is equals to 0.192 into bracket C minus 20. Our question is to find the relation. So let me write the relation. Here is 90L. This 90L. This 0.192C we may write on that side. Then minus 0.192C. And minus, or this term if we write on that side, then 90 into 124.942, this value, and minus 20 times 0.192 is the another value. And now I think this is the linear relation between L and C. See that, length and temperature in Celsius. And this is of the form AX plus BY plus C is 0, but not exactly AX plus BY plus C. Here the relation is in the terms of L and C, length and temperature. So that's it. This is really interesting question which can be easily found with help of the equation of line, where 2-point form is given. Okay, so another question is also similar, so try to solve it yourself, and here we stop now. Thank you.